Okay, so now we're in the home stretch here. Just a few more slides left. So zone transfers. Zone transfers again are the way to have primary DNS servers update other secondary DNS servers to make sure that they have the proper information in their zone. And so now we have a couple of different types of zone transfers that we're specifically gonna look at. There's a couple of other different types of DNS zones that we're not gonna get too into, such as stub zones, but we're just not gonna go there for this particular lecture. So for a full zone transfer, that's transferring everything. That's referred to an AXFR. And so this is going to be dictated by startup authority records, but really what we're doing here is we are requesting complete zone transfers from the master or the primary to the secondary. And so we're transferring everything all at one time. And again, this is going to be one of those situations that we're definitely going to want to use TCP for. And then we have an incremental zone transfer. And the way that we're going to do this is it's called an IXFR. And we're really only going to provide the changes to the zone that were provided from the master to the secondary. And that's going to help us not have to do large transfers all the time. So typically with a full zone transfer, we're going to do that at the beginning of setting up a secondary DNS server, or if there's something that radically changed or there's corruption, we'll do the full zone transfer. Whereas an incremental zone transfer is going to be just to keep those up to date. And so with the DNS notify, this is going to allow the master or the primary to communicate that there are changes to the domain to the secondary DNS server. And so it's going to say, hey, secondary server, there are changes, and I'd like you to request a zone transfer. And then that secondary DNS server is going to request that zone transfer, and then it'll complete that process. Now, if you want to, I would recommend just looking at the DNS zone transfers link here. It goes into a little bit deeper depth on what zone transfers are used for and kind of how it's done. So I would definitely encourage you to look at that as well. So this is going to be, generally speaking, how the zone transfers will happen. So we have this DNS notify here, and it's coming from the master. And the master is going to say, hey, again, secondary, I have changes to the domain, and I'd like you to record, or I'd like you to make a request for a zone transfer. And so that secondary DNS server is going to do a start of authority query, and it's going to query for that record. It's going to obtain that information because, again, that has a lot of the configuration type information for the zone that is important for things like the secondary DNS server to know in order to properly obtain information on the zone and how to do the zone transfer. So then after that, it is going to perform the either full zone transfer or the incremental zone transfer, depending on how it's set up in the startup authority. And then the primary is going to then produce the update and record results for the incremental transfer, or it's going to reply with the entirety of the zone contents if it's doing a full transfer. So that's the back and forth kind of priority there. For how it's going to complete that zone transfer request. Now, something that's a little bit more new with multicast DNS and a little, it's something that's been around for a long time. Excuse me. Which is going to be link local multicast name resolution. Both of these are going to be kind of interesting in their own way. So MDNS was kind of made popular by Apple products in general, and so we're multicasting for DNS queries. And then there's link local multicast name resolution, which is interesting and a little bit frightening from my perspective as a security or incident responder, or me being in security or as an incident responder. So I definitely take a look at these links, specifically link local multicast name resolution. So how link local multicast name resolution kind of came about was when specifically Microsoft was coming up with their operating system, and the fact that DNS is so heavily utilized in our environments, they said, okay, we need DNS. Okay, that's a fair statement. What if we don't have DNS available to us? What do we do? and they kind of had a panic attack for a short period of time. And then it said, wait, I got it. Okay, what we're going to do is we're just going to allow a host to do a link local multicast on the local link and say, hey, anybody around me, do you have this information? And so it allows a host to literally ask other hosts on the network, hey, do you have the DNS information for this particular record? And any random host on the link can say, yep, I have that information, here you go. And so that obviously leaves a lot of opportunity for spoofing of DNS records and other malicious type actions to be done via DNS and link local multicast name resolution. Now, what's even a little bit more frightening is that somebody in the room at some point in time said, wait, what happens if we can't do LLMNR? And then some other genius in the room decided, hey, I got it, okay? Too easy. We're just going to use NetBIOS then. And so we started doing, allowing hosts to be able to do NetBIOS resolution for DNS as well. So although it accomplishes what we need it to from an engineering perspective, we're always making sure that DNS is kind of able to be resolved if possible, but it does come up or provide or kind of introduce a lot more of an attack surface for people to do things like DNS spoofing. So I'd say take a look at these videos and just kind of understand, generally speaking, what multicast DNS is, what link local multicast name resolution is, and just know that they are alternatives for traditional DNS. So then, briefly, some attacks on DNS. Okay, so DNS cache poisoning. So what we're doing here is we are replacing records in the cache with bogus records. So what our goal is here is we want to have the DNS server in the environment able to have some sort of bogus record in their cache. So anytime that a host would query for this record, it's going to get the bogus record or the malicious record. So we're poisoning that cache. And then we have DNS record spoofing. So DNS is a kind of a first come, first serve protocol. So if I know that you make a DNS request for www.reddit.com or www.usbank.com or TCF Bank or whatever bank, and I am able to respond faster with that record, then the first record received is going to be the one that we use. And that's a good thing, generally speaking, because we don't want records to come in after, sort of like a gratuitous ARP request, and have that update our DNS cache and use that value, that IP address for the host. That would leave us open to even more attacks for spoof DNS records. But anyway, if we have a particular DNS query that goes out and I'm able to respond quicker as an attacker with a bogus record that's malicious, then that is going to be a little bit of an issue for us. So we need to do what we can to make sure that the legitimate records are coming in first, and making sure that we don't have people sniffing our network traffic. And so then we have denial of service against a DNS. And so this is, again, the dying DNS type of attack from 2016, where we have a particular DNS service that's taken offline. And then as we all felt, we weren't able to get to Netflix, and we weren't able to get to parts of Amazon, and we weren't able to get to all these different places that utilize that DNS service. So that kind of highlights why DNS is so important. But then on a little bit of a flip side of that, we have DNS that can be used as a method of attack. So we've seen before how we can use DNS as a way to perform denial of service attacks, and this kind of comes into play because of the different types of records that we have. So for instance, those text records are just strings of information. Well, what we can do is we can create a text record that's large, a very large text record. We could even max it out. And then we can start doing those reflected or reflected DNS attacks, where we start sending a whole bunch of records to various DNS servers that we have had them cache the large text record, and then we can start sending out a bunch of spoof DNS requests using the victim's IP as the source, and then we'll send out a bunch of those, and then all of those DNS servers with this really huge text record will all send their replies to this host, and thereby causing a denial of service. So we get that amplification. We're reflecting off DNS servers, and so we're using DNS to actually perform the attack. So just some ways that that we can utilize that type of service as well. So DNS is very, very, very important. However, it's also not very secure. So we'll talk a little bit more about things like DNSSEC, which is kind of leading the security revolution for DNS, and we'll talk about that in Chapter 18. So that's it. We've made it to the end of the lecture here. Please let me know if you have any questions. We can revisit some of these different items in class, especially some of the whiteboarding components, and we can answer questions there. But that's it for DHCP and DNS. Thanks for watching, and thanks for being flexible.